Cool beans. So we will go ahead and get started. First off, does anybody have any specific questions about specific problems from the homework? This could be from section 9.1, 9.2. I know some of you guys covered 9.3 today. We could touch on that a little bit. So yeah, any questions? Do you have any questions? Cool.
Don't even, I like it.
I appreciate the gusto, Ben. I will do my best to give a good roundabout explanation of some stuff. So with, see, oh, it's frozen.
Yep.
Good deal. Let's try, let's see again. Cool. Oh my God. Focus. There we go. Awesome. So with 9.1, you guys covered quite a few different things. So you have population growth. With, and that can be exponential. And that has equations like dp over dt is equal to kp. You can also take a look with regards to if there's a carrying capacity. So dp over dt. So your change in your population with regards to time is going to be some coefficient k, your population, and then 1 minus the population over m, that carrying capacity. And this would be more logistic growth, I believe. And then you guys also took a look at some harmonic exponentials and some harmonic motion, which would be more along the lines of springs. And that goes by the equation of m. I'm going to simplify it a little bit. So nx double prime is equal to kx being our spring constant. Yeah, so then in 9.2, you guys covered direction fields. Which those show all solutions and all of the various slopes at various points on a curve. And this shows all solutions with what I like to call a plus C adjustment. So no matter what sort of vertical translations you have going on, it is all there, which I think can be pretty handy, but they aren't stressed super terribly, really. And especially once you get to the actual differential equations class, you'll focus more on those there. So next thing you guys covered was then Euler's method. And with that guy, we have the general equation y of n plus 1 is equal to y sub n plus h, our step size, times f of y sub n. Yeah, so where h is our step size. And this guy right here is our y prime at the point x sub n, y sub n. So there's that there. And you can attack Euler's method a couple different ways. There's the formula method of laying it all out, or also the table method. Both obviously work well and they work pretty easily. It's just really up to personal preference. Personally, I like to do the formula method. It makes sense in my head a little bit more, but
I understand.
see, yeah, Kelton uses the table method. So it really just depends what your background in math is. And so then because Euler's method goes for approximations, the key thing to remember here is that the smaller your step size, so the smaller h is, the better your approximation is going to be. Sweet. And then let's see, in 9.3, that is just a lot of separable equations and getting into some other aspects of diffie-q. I believe that you guys also were going to do some mixing problems as well. Were there any mixing problems in the web assign?
Not that I saw.
Yeah, so no mixing problems in the web assign, but those are definitely something to keep an eye on. Pretty common for exams, but more so for diffie-q. The mixing problems that you guys get will be pretty basic.
Generally does, yeah, more mixing, but they do come up.
They do definitely come up. They're handy.
Yep.
Yeah, and so the main idea or the main checklist to follow with separable equations is that you want to factor what you have. So you want to separate everything into various x's and y's respectively. You want to separate them so that you have y's on one side and x's on the other. And then you want to integrate once you get to that point. And you will do each of those respectively on either side. And then you can use that to then solve. Sweet. So let's go ahead and get into some problems from the homework. The first one that I am going to run through is going to be number 2 from 9.1. And at any time, if you guys decide that you have a question on something that I'm doing, feel free to send it into the chat. Kelton is going to be watching that pretty closely, and we'll try to answer your question as quickly as possible. And if, yeah.
Sorry.
No worries, man. Yeah. Yeah, just feel free to speak up whenever you would like. We are going to, for sure, run through a couple questions from 9.1 and 9.2. I also picked one out from 9.3, even though that homework for you guys isn't really due until, like, what, next Monday? Yeah, next Monday. Yeah, and then after we are done with those, if nobody has any questions, we will call it a night. So let's get into it. So this question asks, for what values of k does the function y is equal to cosine of kt satisfy the equation 25y double prime is equal to minus 4y? We want to enter them in the comma separated list. Cool. So what we first want to do is we want to find what y double prime is, first of all, in terms of the equation that is given. So we want to go ahead and find our y prime. We have to, of course, do the derivative of the outside and multiply by the derivative of the inside. So we end up with a negative sine of kt multiplied by a k, and I'll simplify that down later. And then our y double prime, we're still just focusing on our sine as what we're taking the derivative of. So this comes out to negative k squared cosine of kt. Cool. So now we want to take this guy and sub it into right here and sub both of them in. So we have 25 times negative k squared cosine of kt is equal to negative 4 times cosine of kt. And then, yeah, so then we have negative 25k squared cosine of kt is equal to negative 4 cosine of kt. Cool. So then because we have, we want to manipulate this guy so it goes onto this side and have just an equation set equal to 0. So we have minus 25k squared. I'm going to simplify a little bit here, and it's going to be plus 4 times a cosine of kt is equal to 0. And from there, it makes it pretty easy to simplify. So let's see here. Yeah, so we are going to divide both sides by cosine. So this cosine is just going to go away. And so then we are left with 4 minus 25k squared is equal to 0. So then we have move this 25 over, and yeah, so we have 4 is equal to 25k squared. Divide both sides by 25. And then we have k squared is equal to 4/25, and k is going to be equal to plus or minus 2/5. And that is for that guy. Now there is a part B here. And so part B is talking about for these values of k that we just found, we want to verify that every member of the family of functions, this is going to be y is equal to a sine of kt plus b cosine of kt is also a solution. So thankfully then it does give us our y prime and our y double prime. So I am going to write those out here. Awesome. Sweet. And then we are going to apply that to the equation that we are given. This 25y double prime is equal to minus 4y. So, yeah. So we are going to get these all on the same side and set it equal to 0. So 25y double prime plus 4y is equal to 0. And we are going to plug and chug. So our y double prime is going to be input into this guy, and our regular y is going to be connected to that 4. Thank you. Awesome, and yeah. And from there, with the rest of the problem, it is pretty much just a proof. You will come out to the exact same values of k, and it'll work out pretty nicely. A lot to remember here when you start having some really long derivatives is to double check your signs and make sure that they're all distributed properly. A lot of what people can get stuck on with these problems is just the vast amount of algebra. And especially when it comes to exams, you want to keep it as simple as possible in terms of how you lay things out. You definitely do not need to fully simplify to your final answer. Yeah, you just, I want to say you don't want to get lost in the sauce of algebra.
That's the way to put it.
Yeah. Sweet. So the next one that we are going to go through here, let me see, let me find it. That is going to be number 7. If I can find it. Okay, so this one, is it going to make me, oh geez. We might not end up doing this problem. Yeah, we'll come back to that one later. But it's a pretty good problem on population growth. Yeah, we'll see if we get to it. So next up we have, let's see, one's from 9.2, so looking at direction fields and Euler's method. This is your homework that's due tonight. So let's see if we can find some good ones here. I'm going to take a look at first number 5, because it is rather lengthy. Sweet. So what are we going to do here? So we're going to use Euler's method. So this is 9.2. Number 5 is going to be Euler's method. We're going to use a step size of 0.1 to estimate y of 1.5, where y is the solution to a y prime is equal to 3y plus 2xy. And we are given the initial value of y of 1 is equal to 1. Cool. And so in WebAssign, when it asks you to round to 4 decimal places, please use your calculator. Use your calculator with these problems a lot. I understand that your guys' exams are non-calculator for the most part, right? Yeah, non-calculator. And so it is, you won't be asked anything too crazy on the exam.
Right.
They'll probably just want you to stick to like a single decimal.
Right. If that.
Yeah, if that.
If generally on an exam, they're going to give you numbers that are easy to compute in your head. WebAssign does not do that. WebAssign is going to give you numbers that you're going to need a calculator for. So use a calculator on this homework. It's going to save you a lot of time and a lot of mathematical errors that aren't even errors, you just round the problem. So.
Yeah. Good old SIG kids.
Yeah.
Sweet. So it looks like we are going to have about 5 iterations of so, or Euler's method. And we are going to go through the first 2 or 3. So we first want to set up by finding y1, and we want to go back to our equation and start from there. So yeah, I will be using the formula method, just as an FYI. Yeah, you can find plenty of videos online of the table method.
There's examples in the book too.
Oh yeah, book is super helpful. Sweet. So we already know what our initial y value is going to be, and it was given right here. Y of 1 is equal to 1. So we can say that y sub 1 is equal to 1 plus 0.1, which is going to be our step size h. And then what we want to do is plug this initial value, our point 1, comma 1, into our y prime. So if we plug in this 1, 1 into our y prime, we are going to get 3 times 1 plus 2 times 1 times 1. And that's going to simplify down to 1 plus 0.1 times 5. Yeah, 5. And so that means that our y sub 1 is going to be equal to 1.5. So then we can then use this in our next equation. So y2 is going to be equal to y1 plus h times f of x1 y1. And our x's are always going to be predetermined by our step size. So we can use this handy dandy equation to remember, and it's going to be x n plus 1 is going to be x sub n plus h. So every x value that we use is just going to be increased every iteration by our step size. So we can then write out that y2 is equal to 1.5 plus 0.1 times, and then we are going to plug our point of 1.1, 1.5 into our y prime. And so that is going to be 3 times 1.5 plus 2 times 1.1 times 1.5. And yeah, this is why you need to use your calculator. Good deal. And so that will give you y2. And that's going to be some number.
Yes.
Yeah, you guys can do that on your own. And so then that will continue on until you get to y sub 5. And y sub 5 will be the final y value that you are looking for. And that's going to be y sub 4 plus h times f of x sub 4, y sub 4. And this point here is going to be 1.4, comma, whatever you guys got for y sub 4. Sweet, yep. And then the x sub 5 that will accommodate this guy is going to be 1.5. Cool. Sweet. So the next one, yeah, so we could go over another one like this, but I feel like this pretty covers it well. Number 7 on your guys' homework is super similar to this. You are doing 4 steps of Euler's method. Your step size is a little bit higher. You have a slightly different equation, but a really simple initial value. So I think it should be pretty straightforward for you guys. So let's take a look at number 11. Cool. Euler's method again, but this time a word problem with some electrical currents, circuits. I can read. Oh. Sweet, yeah, so off of, can you go up and grab me some more scratch paper?
Yes, ma'am.
Sweet, thank you. Yeah, so this is going to be 9.2, and this is going to be number 11. Cool. So let's see, they have a little setup here. Yes. Cool. Great. So we're looking here, a simple electric circuit. Our R is going to be equal to 10 ohms. We have an inductance of 2H, 2 henries, and our voltage is going to be equal to, let's see, V is going to be equal to 20 volts. Awesome. So let's see. It starts off with giving you your current I, that is not going to be I, di dt is equal to 10 minus 5I, where I of 0 is equal to 0. Wants you to estimate the current in the circuit half a second after the switch is closed. So what they look to do here is they say that our capital F of t sub I is going to be equal to 10 minus 5I. Good little stack, thank you. Sweet. Our I sub 0 is equal to 0. T sub 0 is equal to 0. And we are looking at a step size of 0.1. So we are going to set up just as we would set up any other Euler's method problem. So our I sub 1 is going to be equal to T sub 0. Yeah. t sub 0 plus h times f. Actually, I'll rewrite that a little bit. Times f of t sub 0, I sub 0. And so you're going to get 0 plus 0.1 times, that's going to be 10 minus 5 times 0. So nothing too crazy. We get an I sub 1 equal to 1. Yeah, 1. Very, very fancy. So then I sub 2 equal to 1. Oh yeah, that's not a t sub 0, that's an I sub 0. Cool. So it's going to be equal to I sub 1 plus h times f of t sub 1 I sub 1. It's going to be equal to 1 plus 0.1 times 10 minus 5 times 1. Wow. Oh. And so this, let's see, 10 minus 5, 5.1. Yeah, so this is going to be equal to 1.5. Really breaking the noggin with this arithmetic here.
This is the type of stuff you could possibly see on an exam.
Yeah.
This would be an example of a question you may see on an exam without a calculator.
Yeah, because it's a good word problem.
Right.
You know.
Right, and the math's not crazy hard.
Yeah, cool beans. So yeah, it'll go on like that some more, and then you'll get down to I5 is equal to I4 plus h times f of t, so 4 I sub 4, and yeah, good deal. Cool. So that is 9.2 number 11. Wow, yeah, it'll be a quick one tonight.
It will be. It's good.
Yeah. If you guys have any questions or any specific problems that you want to look at, definitely give us a shout.
Speak now.
Yeah. We're getting to the point where it's forever hold your peace.
Yes.
Cool beans. Yeah, so the next one that I'm going to look at is from 9.3, and it's one that I just thought was pretty representative, I believe. Not too crazy or anything, and we're going to look at number 4. Awesome. So we are going to find the solution. dy dx is equal to 9x e to the y when y of 0 is equal to 0. All right. Awesome. So with any separable equation, we first want to break it up into our x's and our y's. So that means moving all sorts of things about. This is set up pretty nicely. So what we want to do is move this e to the y over to this side, and we are going to move this dx over here, do a little switcheroo. And so we can rewrite this as, let's see, we'll keep it without fractions. So we will say e to the negative y dy is equal to 9x dx. It's super common that you get like an interesting fraction on this left-hand side with your dy, but your right-hand side usually comes out pretty nicely. But so once we have it into this separated form, we are going to go ahead and take the integral of both sides. So integral of e to the negative y dy, a very easy peasy one to go for, and something that you really should remember. So the integral of e to the y is just going to be itself, same if you're taking the derivative. And so the only thing that makes it any different here is just this negative. So we need to put that negative in front. So negative e to the negative y is going to be equal to the integral of 9x dx. And so that is going to be 9/2 x squared. And then the most important part is your plus c. And especially when it comes to diffie-q, those plus c's are super important. So, and solving for this plus c is also a big part of the problem. So this is where we use our point y of 0 is equal to 0. So we will plug this in. So we will say that negative e to the negative 0 in this case is equal to 9/2 times 0 squared plus c. So e to the 0, negative e to the 0, anything to the power of 0 is going to be 1. So we are going to have a -1 on this left-hand side, and then we're just going to have a 0 plus c. So in this case, c is equal to -1, and then we are able to write out our equation as such. So negative e to the negative y is equal to 9/2 x squared minus 1. Now, the interesting part with separable equations is most often not the integration itself, but the algebra that comes after when you're trying to isolate your y. Because you get a lot of interesting fractions over in this integral, you end up with a lot of natural logs.
Yes.
Yeah, so in a bunch of people, I believe they're different type of problem, but so do you not have to get it in solely like a y on the left side and then everything else on the right? So like we have that e to the y on the left, and that's okay just because it's a constant that's there, it's whatever.
Yeah, so this is the simplification of the algebra to try to isolate that y is another point where you could get really, really lost.
Are you talking about when we separate the x and the y, like that second step that we have out there?
No, what she's talking about where you're trying to get that y alone on the left.
Okay, yeah.
Up to an e.
Okay.
Yeah, so yeah, on an exam, just leave it like that.
Okay.
My diffie-q professor even was like, once you get it to like this sort of step, just
Okay.
leave it as is.
On WebSign will take that. Unless WebSign specifically states get to form y equals, WebSign will always take that answer, and that answer is correct.
Yeah. So
But you might as well simplify it.
Yeah.
Because we got time, so.
yeah, and it's, I don't know, I really like the simplifying.
Yeah.
Yeah, so the first thing that we're going to do here is we're going to distribute this negative. We're just going to divide everything by a -1. So we get e to the negative y is equal to 1 minus 9/2 x squared. And so what I did there was that this became a negative 9/2 x squared, and this became a plus. So I just switched them around a little bit. And so then here we go. We want to take the natural log of both sides. And so we can rewrite that as negative y is equal to the natural log of 1 minus 9/2 x squared, which isn't too bad. And then we just want to do with the negative the same thing that we did earlier and just put it on the other side so that y is equal to a negative natural log of 1 minus 9/2 x squared. And so this would be the super final, super complete answer.
So you would have to get to that third step, or is that just like kind of over the top, like it looks good, but it's not necessary?
So in WebAssign, at least for WebAssign in this problem, it wants this final form.
Okay.
Because the algebra isn't like super disgusting.
Okay.
And if it just leaves you like a blank empty box with like nothing before it or nothing after it,
Okay.
then I would say it's fine for both of them.
Right. Okay.
It might take like a little bit of experimentation to see what WebAssign will accept. But I wouldn't see them having a problem accepting the unsimplified form.
So typically, if WebAssign wants something y equals when you're doing differential equations, they'll have it y equals, and they'll let you put in the rest. If not, if they just have a box, they will accept. Assuming it's correct, they will accept whatever that's the answer you get when you miss grade.
Yeah. Yeah, their simplification program that they run in the background of their
It's really
website
nice.
is pretty,
It's
it's
really
pretty
nice.
nice. I've seen some really gross things typed in there, and it works out to be okay.
Yep. So yes, it's a question by question basis, but unless it specifically states y equals and makes you input y equals something,
Yeah.
you should be able to leave it. Yeah. Yeah.
And something for WebAssign as well, when it comes to 9.3 and DiffyQ in general, review your common integrals because they can sneak some pretty nasty ones in there without you realizing it. And it's also not uncommon to see like integration by parts thrown into separables.
I don't know if they do a lot in calculus. It comes up to DiffyQ
Yeah.
for sure.
Definitely, you guys won't have to see anything
Yeah,
crazy.
review your methods of integration, strategies of integration, because it probably is going to come up in calculus. I don't know for sure, but it probably will. Integration by parts and all that fun stuff is going to come back.
They have an exam next week.
Yes.
Yeah, you have an exam next week.
Yeah.
That was
So,
fast.
yeah, so review those integrals, because you don't want to get caught up on something when, you know, it's just an integral that they expect you to know. So.
Yeah, and so you guys will have your exam on the 20th. Okay. Yeah, so an exam on the 20th. So 9.3 will be due the day before your exam, and then you will have 9.4, which is population growth models, due on the 21st, so the day after the exam. Not ideal. Population growth is a lot of word problems. So yeah, maybe get a head start on that one a little bit.
Yes, just yes. You're going to spend a lot of time on 9.4 most likely. So. Maybe look at it sometime on this nice little break.
Yeah, 4-day weekend.
Yeah,
So,
I know it's probably the last thing on your mind, but it's not terrible.
yeah,
So.
good deal. Well, yeah, those are all of the problems within reason that we chose to go over. Do you have any specific like concept questions or anything? No? Okay. Cool. And then, Ben, do you have any questions? No? You're good? Cool beans.
All right.
Sweet, thank you. Yeah, in which case, have a wonderful evening. I think this will be all for us tonight.
Yeah, you guys are free to go. Enjoy the evening, enjoy the rest of the week, enjoy
Great to see you,
break.
Solana.
Be safe this weekend.